These days, it's important to take care of your mental health. We all have a bad day sometimes. For example, it's the afternoon. Math Dog is still in bed. In fact, she's still in her jammies. This toy might help her a little bit. But you know what really can help is art and beauty. My wife painted this fine painting, which I find calming to have in the house. We have other artwork. My wife's mother painted this watercolor of Mount Tam. Now, I'm not a great artist, but I made a collage that I thought Math Dog might find comforting. When she comes back, maybe she'll enjoy this collage I put together for her. Today, our intermediate algebra students, and anyone else who's interested, is going to look at variation problems. We'll talk about direct variation. Here's the equation for it, and the K is always going to stand for the constant of variation. Yes, I know it's not really spelled with a K. Well, an example of this is if you have a job, and many jobs you get paid by the hour. I'm not talking about commission or other sorts of pay, but in this situation, if you work 0 hours, you make $0. Now let's say that your constant of variation is $10 an hour. If you work 1 hour, you make $10. If you work 2 hours, you make 20. You get the idea. 3 hours, you would make 30. You could graph a line. Now, if you got an increase in your salary, let's say they bumped you up to $15 an hour. So your constant of variation, K, has just increased. Well, that's great. 1 hour, let's say you make $15. Still, you got to go to work. 0 hours gets you $0 at this job. 2 hours, 2 times 15 would give you 30. 3 times 15 would give you 45. You would still have a straight line, but it would be steeper. It would have a greater slope. You've studied slope. It's very much like y equals mx plus b. It's just that we always start at 0, 0 if it's direct variation. All right, well, that's not the only kind of variation. Let's look at inverse variation. Inverse variation has a different equation. You would say that y varies inversely as x. Here you would say that y varies directly as x. Here, as x gets bigger, y will get smaller. Let's take a look at an example. Let's say you have a 90-mile trip that you have to travel. The 90 would be your constant. We're not taking a longer trip or a shorter trip today, 90. X would be your speed in miles per hour. We could use different units. So let's see here. If we were to go 30 miles per hour, let's see here, 90 divided by 30, that would take us 3 hours. So if we go 30 miles an hour, it'll take us 3 hours. Let's say we increased our speed. The freeway opens up and we can go 60 miles per hour. Well, let's see here. 90 divided by 60 equals 1.5. So if we could go 60 miles per hour the whole way, it would take us 1.5 hours. Now, I definitely don't suggest you do this, but if you could go 90 miles per hour, don't try it, you would get there in 1 hour. Let's put some more points on our graph. If you could go 45 miles per hour, well, let's see, 90 divided by 45 equals 2. So 45 miles per hour would take you 2 hours. Now these points are actually curving. If we went 15 miles per hour, that would take us 6 hours. That'd be way up here on the graph somewhere. And so we would get a curve, inverse variation, always something like that. Now, it would never take us no time whatsoever. It's always going to take us some time to get there. Even if we could go the speed of light, this curve would get very close to the x-axis, but it would still take some time. And in this direction, we can go very, very slowly, 1 mile per hour. It would take us 90, way the heck up there, hours to get there. Remember domain restrictions? Here we have a domain. The domain x cannot equal 0. We're not too worried about domain in today's lesson, but this is a good example of it. You can't go 0 miles per hour, you'll never get there. If you don't believe me, go sit in your car, don't take the parking brake off, don't turn the ignition key, and see if you ever get there. You won't do it. Now, there is another type word that you'll see for variation. We have direct. Let's take the 0 off. We'll just stick with that. Direct variation, inverse variation, and joint variation. Joint variation, the y might depend on more than one thing. It might depend on x and z, and you can have more things up there, and sometimes they're going to be squared with an exponent of 2 or cubed with an exponent of 3 or other exponents. Sometimes you'll have joint variation, everything up top, and they'll also say it varies inversely as something else. The inverse things go on the bottom, all the other things go up top. Now, if you have your book, open it up to page 428. Here are some of your homework problems. If you don't have your book, pause the video, go get your book. On problem number 6, it asks you to write this out. This is the answer. And what they tell you, I'm not even looking at the book, but I know what they're telling you. They're saying that y varies directly as q and t. If it's direct variation, direct variation would be 1. If it says jointly, you have 2. So actually this would say y varies jointly as q and t. Everything goes up top unless it says inversely. In problem 10, it would say that y varies directly as a to the power of 5, so that goes up top, and inversely as b, so b goes on the bottom. The constant always goes up top. Now they'll have some other problems, of course. Sometimes they will give you 2 values. So in a section that includes problem 12, they tell you this is direct variation. And they give you 2 values. All right, if it's direct variation, you write the appropriate equation. And then you plug in the values. If y is 5, you substitute it in. If x is 30, you substitute it in. Now you still have to solve for k. So to do that, you say, well, let's see here. I know how to get rid of this 30. I'm going to divide it away, and I'm going to do that on both sides. And if I can reduce my fraction, I will. 5 over 30, that's 1/6. So what they ask you to do is to figure out the constant of variation, we've done it, and then to write the appropriate equation. Well, let's see, if it's direct variation, it's y equals the constant times x. Haha, now, on a later problem, they tell you it's inverse variation. Okay, you write the appropriate equation, then you substitute in the correct values. In this case, y is 20, x is 9. You know how to solve that for k. If k has been divided by 9, you multiply by 9. And if you do it on one side, you do it on the other. You can do this in your head. 9 times 2 is 18, and there's a 0 hanging around. 180. Hey, that's my constant of variation. What's my equation? Well, I go back. Y equals the constant. The constant we just figured out is 180 over x. Now there's some word problems on the assignment, and they can get a little bit tricky. All right, well, we're gonna have a lesson this week on Thursday, and I can help you with some of those. Email me if you have trouble. Let's take a look at one other thing. Well, two actually. Let's take this fine piece of wood that I've been using. Nice little piece of redwood here. And how much weight could this support if we put it like this and started adding weight to it? How much until it snaps? Is there some mathematical way to figure it out? Well, you betcha. The maximum weight it can support, if we made a bridge out of it and supported it at the ends, the maximum weight it could support, you have some constant with a K. I misspelled it. Yes, you use a K. Well, I don't know what that is for redwood, and it would vary. For steel, it would be stronger. For other material, it would be weaker. But I do know this. This is not the strongest way to support it, because you multiply the constant times the width times the height, see this little height, squared. And then on the bottom, it varies inversely as the length. So if you go look under your deck at your house, or if you've ever seen a building that's under construction, you'll notice they don't put the wooden members like this. They put them in this orientation like that. That's gonna make it stronger than if you put it like this. Why? Well, because the height gets squared. So if I'm trying to support a lot of weight with this piece of wood, I would put it in that orientation. I would not put it like this. And that intuitively makes sense. If I step here, it's gonna snap a lot easier than if I start piling the weight on here. If you try challenge problem number 54, this equation will help you. That's a challenge problem. It's a tough one. If you want to give it a shot, that's great. If you don't want to give it a shot, okay, kind of like Math Dog, you lie in your bed until the afternoon and take it kind of easy that day. All right, folks. Hey, I look forward to seeing you at our Zoom meeting, and I hope that this helps you a little bit. Thanks. Bye.